And you're welcome. In our last lesson, we created a script that allowed us to control a game object. So basically, if we click the left arrow, our cube is going to rotate left, and we press the right arrow key, our cube is going to rotate right. And just right here, we can actually look at that C# script that is controlling the behavior of that game object, which is our cube within our scene. So basically, right now, before we move on and learn how to instantiate game objects within our scene, let's go ahead and look at the difference between a key term that seems to be confusing, and that difference will be between the programming and scripting, because when we're writing our code using Unity, we're actually scripting, not writing a full program. So let's go ahead and quickly look at that difference, and from there we'll move on to much more interesting topics. So right now in this presentation, we're going to understand the difference between programming and scripting. So basically, programming, we have 4 levels. So the machine level, which is the first level, and it actually runs with binary. So for instance, a Samsung J7, which is powered by a 1.7 gigahertz octa-core processor, would actually look at these values for zeros and ones as the inputs. So that's how the machine works, and this is actually low level. This is super low level because you won't understand instructions based on binary data, which is simply zeros and ones. Now for the assembly language, just like this image shows, you have a shorthand form of displaying the machine language information, but using a shorthand keyword. So you can see words like load, add, store, or halt that can represent values for an assembly language. Basically, it's a symbolic representation. So for an x86 Microsoft processor, we can see keywords like POP, JMP, or int to interrupt a process. So these are example of keywords you can see for assembly language. Now the third level, which is the compiled language or high level language, and it's much more intuitive and readable. So we can see this using C#, C++, or the C programming language. Also, JavaScript is an example of a compiled language. Basically, your script or your code needs to be translated into machine code by what is called a compiler, and this is an example of an if statement, and we saw this example in our last lesson where we created our if-else statements. And then finally we have the interpreter language. Now this is where Unity scripting comes into play, because with the interpreted language, it's not compiled by an interpreter, but you need another program that interprets your code. Now this represents the highest level, and Unity is actually the interpreter for C#. So basically, what is a script? Because we create scripts within Unity. So a script is compiled by another program, just like we mentioned right now, C#. Unity compiles C# scripts. So a compiled program is an executable program that can be run. For instance, you have your Microsoft Word, your simple calculator. When it's compiled, it gets built into an executed program. So a script is compiled by another program, but a much more symbolic definition for a script is that it's an efficient method of coding that allows rapid iteration. So basically, it doesn't go through the regular path of your regular programming language, where you take it from machine language, and then it has to be compiled and then later on interpreted. So Unity scripts are interpreted by the engine. And like we mentioned, programming languages need to be compiled from machine code using a compiler, and then it gets built into an executable program. And once that happens, it becomes difficult to edit your source code, except you use some specialized software to reverse engineer that process. So one good thing about scripting is that it can be debugged easily, and then the interpretation can be very fast. So imagine we have instructions we wanted to run in Unity, like we can see in our example. So for this simple Unity script we have here, where we're changing effects and moving this cube. This is an example of a script, and each time we run this directly within Unity, we can actually see that effect without necessarily having to go through compiling this and converting the script into an executable program. Basically, Unity is working like the scripting engine for our code. So we're writing our script and then attaching that script to a game object, And basically that's what the difference between a script and a program is. So in our next lesson, we're going to be instantiating our game objects and moving on from there. Thank you very much for watching.